Section 4.8, we look at congruence transformations. So to finish up our chapter on congruence, we're going to look at ways we could change or move a figure and still maintain congruence. And that's what a transformation lets us do. It's an operation that moves or changes a geometric figure in some way. Now that new figure that we get, we're going to call the image. And we're again talking about congruence transformations because they give us a new shape, but it doesn't change its size or shape. So down below we have the original image we start with. If I apply a transformation, it gives me an image in a new place. There's three types we're going to look at: a translation, a reflection, and a rotation. And it's important to remember as we go through these, when we create the new object, the new image, that it's congruent to the original. So the first one we're going to look at is a translation. And a translation can move an object horizontally and vertically in the coordinate plane. It shifts on the plane. It's not rotating, it's not changing in size, it's not changing in the orientation it faces, it's just shifting on the plane. So I have a triangle ABC to start. Let's say I shift it we went right and then up. So we're going to count the number of units it changed. So I went from -4, -4 to a new point that is 6, -2. This is the image of C, or we'll call it C prime. So if we look at what we did there, we went from -4 to 6. So we actually went 10 units more in the x direction and 2 units up. So that shifts all of the points to our new image. Here's B prime and A prime. And if we look, all of the x values change 10 and the y values change 2 in the positive. So we can use that to see our translation notation, which we have up in this top right corner. And that tells us we go from a point in the original to the point on the image, where we have an A and B value, where it's the change in the x direction and the change in the y direction. So if we were going to look at the translation we did, we took every point from xy on our original to x plus 10, y plus 2, or we added 2 to the x direction, 10 to the x direction, and 2 to the y direction. Now, let's do the same thing to the object we have down below. So in this one, we took each point in our original and moved it down. Let's change colors on that marker, so the pen, so we can see it better. We move the points down. So if we look, I didn't move left or right any in the x direction, but I did move down 1, 2, 3, 4, 5, 6 units down in the y direction. So now our new point, we'll put 2 dashes there, changed, so it's now 0, -9. And in fact, C, the image of C would do the same thing. It's still at -4 for x, but now it's -13. I'll try again, -10 for y. For this one, we could write it as xy goes to x, because the x didn't change, y minus 6. Now let's look at a little cleaner example. So here I have my triangle, and I want to do 2 different translations. The first one, I'm going to take my point xy and go to x plus 5, y minus 2. If we look at that, we have to first interpret what that really means. Now x plus 5 means I'm going to move 5 to the right, 5 in the positive x direction. Y minus 2 means I'm going to move down 2. So I'm going to take each point, move 5 to the right, down 2. So 5 to the right, down 2. Puts me at this point here, which would be 9, -2. Now let's just copy that. So we go to a new point here, and the third one here. And this gives us our new triangle, which would have the coordinates 0, 3 would become 5, 1. And 0, 0 would become 5, negative 2. So it shifted 5 to the right, down 2. Now let's do the other image. We'll get rid of these. So now they want us to go x minus 3. X minus 3 means we want to go left 3, and y plus 5 means we're going to go up 5. So each point is going to go left 3, up 5. Left 3, up 5, left 3, up 5. And it's not real clean here. Let's kind of clean it up. So 4, 0 becomes 1, 5. 0, 0 becomes negative 3, 5. And 0, 3 becomes negative 3, 8. And our triangle looks like this. So that is a translation. Next, we're going to go to a reflection. In a reflection, we have two different types. We could reflect about the x-axis, and we could reflect about the y-axis. First, let's look at the x-axis. So we're going to reflect in this direction. It's like a reflection. Now, before we get to the notation, let's think if we were going to copy this object over. So I have points for the object. And if I think about reflecting the points first, then I can reflect those points and then connect the lines afterwards. So if I reflected that first point close to the origin, underneath it would go to 1, negative 1. So I was 1 unit away, it reflected down to here. I do the same thing over here. For my point in the bottom right, I have my new point, and I could do the same thing. I went over 3, up 5. I'm going to do the same thing, go over 3, this time down 5. And I have my new point there. So I've reflected each of those points. I can now connect them to make my triangle, which is my reflection about the x-axis. Now I have something up in the top left, which is my notation for it. And when I reflect about the x-axis, you may notice all I'm doing is changing the sign of my y value. So for example, I went from 1, 1 to 1, negative 1. I went from 7, 1 to 7, negative 1. And I went from 3, 5 to 3, negative 5. So I changed that y value, it flipped it underneath. Okay, now let's do another one. We'll look now at reflection about the y-axis. That's going this direction. Do the same idea. I started at 1, 1. I'm going to go 1 unit away on the other side. I went to 3, 5, so I'm going to go 3 units over on the other side. And 7, 1, I'm going to go 7 units on the other side. I connect my lines, and here's my reflection about the y-axis. I look at my points now, and like my notation says, I just changed the sign of the x value. So 1, 1 becomes negative 1, 1. 7, 1 becomes negative 7, 1. And 3, 5 becomes negative 3, positive 5. Let's do another one. So now I'm going to draw an image of the reflection about the x-axis of this triangle. And if I look at the points to reflect them about the x-axis, I'm going to go down 1 from here. Up here I'm 4 above the line. I'm going to go 4 below. And I'm 4 from there, that first one, or I should say top left. You can't see where I'm pointing. gives me my 3 points. And if I went through and labeled the points, I changed the value of the y-coordinate. Now as I reflect about the y-axis, I get my first point by being 1 away, then I'm 5 away, so that looks like it's 4, -5, and -5, or I should say -5, 4, and then -5, 1. I get my 2 reflections. Reflection about the y-axis, and the reflection about the x-axis. Okay, our last one is a rotation, and a rotation can either be clockwise or counterclockwise, and we typically go up to 80 degrees, or 180 degrees. If we go any more than that, then we can just talk about going the opposite direction. So the angle of rotation is formed by the rays drawn to the center of rotation. So let's draw some rays. Now typically, we're going to have the center of rotation be the origin. So I look at my 3 points here. I have A, B, and C. I'm going to look at first point A. To go 90 degrees, I would draw 2 rays that give me a 90-degree angle. So that center of rotation, rotate the rays around, I get my new point for A. And if we notice, the coordinates for that are 1, -2. But better yet, I can see I went over 2, up 1. Here I went down 2, over 1. So it's like the same type of triangle, but it's just turned. Now for B, I go over 4, up 4. If I do the same thing, I get my new point for B, which is going to be 4, -4. And now C, I went over 6, up 4. I'm going to go down 6, over 4. And I get C, which is 6, -4. And we actually can see a pattern there that what we're doing is switching the x and y values and changing the sign of the y. Now this isn't a clean rule that we use all the time. It just happens to work when we've rotated 90 degrees. If I rotate 180, which we'll do in a moment, it's not going to work the same way. But it's important to notice. It'd also be good to just trace this and then rotate your paper, and you can see it rotates about that center of rotation. Now, let's say we want to go 180 degrees. So I went over 2, up 1. I'm going to do that same thing, the opposite direction. That gives me a straight angle. This gives me my new point. We'll put A double prime. To go to B, I'm going to go, I went right 4, up 4. I'm going to go left 4, down 4. B double prime. And C, I went over 6, up 4. I'm going to go left 6, down 4, and get C. I can now connect them, and this will be my rotation of 180 degrees. And this one we can actually see a pattern. We've changed the signs of both the x's and the y coordinates, and that will work whenever we do a rotation of 180 degrees.